Hello and welcome to Crazy Math Productions. Today we're going to be looking at some word problems involving systems of linear equations. Let's go ahead and start off. If you follow Crazy Math Productions, you know that we use a system. We like to say let, write, solve, check, sentence. So what we're going to do, we're going to take the situation, we're going to define our variables so that we know what we're doing as we're approaching the equations, what they mean. We're going to write an equation, or in this case, a system of equations. We're to solve. We're going to check to make sure that our answer makes sense. And then we're going to write a sentence explaining to the reader exactly what's going on and contextualizing the answer, making sure that it makes sense in context. Okay, so let's go ahead and get started. A rectangle has a perimeter of 18 centimeters. Its length is 5 centimeters greater than its width. Find the dimensions. Well, we know that if we're dealing with number one, find the dimensions. That's the most important part of the problem. If we're trying to find the dimensions of a rectangle are going to be length and width, and they mention it here, length and width. So I'm going to say let L equal the length, let W equal the width. And I could be more specific. I could say the length of the rectangle, the width of the rectangle, but for now that will do. So I've defined my variable. Now I want to write an equation, or in this case, two equations. Since we're dealing with a system of equations, in this case, we're going to deal with at least two equations. So a rectangle has a perimeter of 18 centimeters. Its length is 5 centimeters greater than its width. So again, if you followed Crazy Math Productions, you know that we like to use multicolors. So I'm going to start with this one. Its length is 5 centimeters greater than its width. So its length is equals 5 centimeters greater than its width. That's one equation. Now, there's no way I can solve for L or for W. There's two variables. Generally speaking, however many variables you have, how many different variables you have, that's how many equations you'll need to be able to work with the system. So here, two unique variables will need two equations. Now, it also tells us that the perimeter is 18 centimeters. If you're familiar with a rectangle, you know that perimeter is going to be two lengths plus two widths. If you think about the actual rectangle, excuse me, two lengths plus two widths is going to give you the full perimeter. So our perimeter we already know. Normally it would be equals P, that'd be our perimeter. But we happen to know in this case that the perimeter is 18 centimeters. So that's my setup here. I'm ready to go. So we've done our write. We've written our two equations. Now we're going to solve. Now, it doesn't really matter how you want to do this. You could solve it. Remember in the unit we've done solve by substitution, solve by combination. You could solve any way that you'd like. I'm thinking probably solve by substitution is going to be probably the easiest way. And there are several ways that you could do solving by substitution. I'm going to try two different ways. So one is the traditional solve by substitution, and that is that we have the length already solved for, and we're just going to put this, the W plus 5, instead of the W, instead of the L, excuse me. So we're going to have 2 on 2, something, whatever we plug in for L, plus 2W equals 18. So we're going to plug in W plus 5 instead of the L. And now we just solve. First distribute, then combine all of your like terms. Please remember key change or you get burned. Then get all your variables onto the same side. First addition or subtraction. multiply, divide. And so we have W. We can plug it back into the red one. L equals, well, if W is 2, this would be 2 plus 5. Or L equals 7. So that way we have both variables. Now the other way that you can do substitution is say, you know what, we already have L by itself. So we're going to try to solve for L in the blue equation. So 2L plus 2W equals 18. We can subtract 2W. 2L equals 18 minus 2W. Divide by 2. And L equals 9 minus W. So now we have L by itself, and we have L by itself in the blue one as well. So we can just sort of squish them together. W plus 5 equals 9 minus W. And so now we can solve. So first distribute, nope. Then combine all of your like terms, nope. Please remember key to exchange or you get burned. You could do that. Then get all your variables onto the same side. So we're going to add W to both sides. So W plus W is 2W. Then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. So W equals 2. So you can see it's a little bit more work on this side, but it is a little bit more straightforward to understand. So whichever method you prefer. And now that we have W, we're going to do the same thing. Plug in. So L equals, in this case we think W is 2 plus 5. So L equals 7. So we have L, we have W, which of course are the length and the width. So however we've done that, whether you're just plugging in or if you're solving for L in both equations and sticking the two together, it will work either way. All right, so we have solved. Let, write, solve. Now we need to check into a sentence. So let's check this. In the red equation, let's make sure that this makes sense. So again, did you have to do both methods? No, I was just trying to show you that you could do it either way. So you needed to show the let, define your variables. You needed to write the equations, then you could choose, and you could solve by linear combination as well. It doesn't matter how you do that, as long as you're following all the rules of algebra. And then we're going to check it. You do need to do this. For the red, let's see, we think that the length, well, what's the length? The length is 7. It's supposed to equal the width, which is 2 plus 5. I'm going to put a little question mark because I'm not sure. So 7 equals, well, 2 plus 5, that's 7. So yes, that works. Now let's check the blue equation, see if it works for the blue equation. 2 times the length, well, the length is 7, plus 2 times the width is, width is 2, equals the perimeter, which is 18. So I'm just copying this down but plugging in the variables. 2 times 7 is 14, plus 4, we think. 14 plus 4 is 18. And that works. So we have done let, write, solve. We've checked it. And now we want to write a sentence. Now, let's make sure that we're answering the question. This should be conversational. Find the dimensions. Well, if I were saying in a conversation, so I could say the dimensions are, they are. You want to answer in a complete sentence and explain from the problem what's happening. So they say find the dimensions. So I'm going to say, okay, the dimensions are. Let's see, don't go with these. The width was 2. And what was the unit? Let's see. Centimeters. Okay, so 2 centimeters by 7 centimeters. And there we go. Let, write, solve, check, and sentence. So, good bit of work, but it's worth it. Okay, let's try our next one. Timmy has 180 marbles, some plain, some colored. If there are 32 more plain marbles than colored marbles, how many colored marbles does he have? Well, I'm going to put my little reminder over here. Let, write, solve, check, and sentence. Okay, so let's sort of put this together, see what's going on. We're going to let. Looks like we have, let's go, excuse me, let's go straight to the question. How many colored marbles does he have? That's the question. How many colored marbles does he have? Well, it looks like in this situation, we're probably going to need both plain marbles and colored marbles. So I'm just going to say let C equal the colored marbles, number of colored marbles. And I'm going to let P equal the number of plain marbles. Okay? So basically, as we're going through here, they have two different statements they've made. Timmy has 180 marbles. That looks like that's going to be an important statement. And it says there are 32 more plain than colored. So just looking at it and trying to think how strategically you're going to work this, it looks like that's probably where my two equations are going to come from. Maybe some extra information, but that's probably the main statements that they've given me. So we've done our let, define our variables. Now we need to write some equations here. Now anytime they tell me a sum, 180 marbles together, there's two different types and there's 180 marbles, that's an equation right there. The colored marbles that you have plus the plain marbles that you have, the sum is 180. You can add them up and that adds up to 180. Now also, there's another equation lying there somewhere that says there's 32 more plain marbles than colored marbles. Well, there's different ways you could write this. My favorite way of doing it is to say, you know what, how many more, which one has more, the plain or the colored? But there's more plain marbles, so I'm going to do the one that has more first. The one that has less, I'm going to subtract from the one that has more. So the one that has more minus the one that has less equals the difference. There are 32 more of the plain than there are colored. So if I do plain marbles minus colored marbles, it equals 32 marbles. So that's my favorite way of doing that. And again, it's not the only way, but it's just a way you could do it. Okay, so let, write, solve. Now, as we're looking at this, you know, this is almost perfectly set up for linear combination. All I need to do is to switch the P and the C. So that's exactly what I'm going to do. Okay, so you notice that P are both positive. We have a positive 1C and a negative 1C here. Well, that's exactly what I want for linear combination. I want to have opposites, positive 1, negative 1, and that's exactly what I have. So I'm going to go ahead and add the entire equations. So P plus P, 1P plus 1P is 2P. C minus C is going to be 0, and 180 plus 32 is going to be 212. So let's go ahead and solve for P. All right, so there are 106 plain marbles. Well, we need to go ahead and plug into one of these to figure out how many there are of the other. I'm going to plug into the red just because I think it looks a little easier to work with. So C plus P, which happens to be 106, equals 180. Well, we're going to solve, subtract 106 from both sides. C equals the 74. All right, so we have solved. Let, write, solve. And as we did our solve, we picked a method, in this case linear combination, solved for one variable, and then plugged in, it doesn't matter which one you plug in for, plugged in and solved for the other. So now we've done let, write, solve. Now we need to check, make sure that this fits the situation. Okay, let's check this. So in the red, I believe that there's 74 colored marbles, plus there are 106 plain marbles. That's supposed to equal 180. Does it? Well, let's check. 74 plus 106. Yes, that is 180. Now let's check the blue. Now, plain minus colored equals 32. Let's try to see if that works. There are 106 plain minus 74 of the colored. That's supposed to equal 32. Well, let's see. 10 minus 7, 3. 6 minus 4, 32. 32. That does work. And so we have checked it, and it seems to check out very nicely. And let's answer in a sentence. Now, before you answer in a sentence, it's tempting to say there are 106 plain marbles and 74 colored marbles. The problem is you've got to read their question. They want to know how many colored marbles does he have. So think about if I were in a conversation, how many colored marbles does he have? Well, he has however many colored marbles. So that's how I'm going to answer the question. I'm going to say he has 74 colored marbles. All right, and that is all 5 parts. Okay, we're going to move on to the next one. I would encourage you, as we start to go through, as soon as you feel comfortable, I would really love you to try and pause the video, see if you can do it on your own, and then come back and redo it if necessary. Okay, let's look through. The most important part of any of these word problems is the question. How many of each type of ticket were sold? So that's what we're after. How many of each type of ticket? Well, it sounds like there's multiple types. What are those types? The theater sold 900 tickets to a play. That looks like the sum. Floor seats cost 12, balcony seats 10. Total receipts were 9,780. Okay, well, let me go ahead and jot down let, write, solve, check, sentence. One of my students had said Lil Wayne sings children's songs. You can come up with any acronym you like. Try to get that to work for you. All right, so what we're dealing with here, we're dealing with dollar value and sum. So I like to think of this as quantity, how many, and quality, and that is how much. What's the value? So that's where my 2 equations are going to come from. Now, before I go ahead and write those equations, I do need to define my variables. So a theater sold 900 tickets. There's floor seats. I'm going to say let F equal the number of floor seats. Let's let B equal the number of balcony seats. And so now let's look at the quantity, which is how many, versus the quality, because they've described both of them here. Well, the quantity, how many are there? Well, you know that you just add these two up. The floor seats plus the balcony seats. And they sold 900 tickets, so that's how many there were. Floor seats plus balcony seats, 900. Now we have to deal with the quality, how much, or the value. So the quality, well, let's think. All right, floor seats cost $12 each. So $12 times each floor seat is the value of each floor seat. And the balcony seats were $10 each. So $10 times the number of balcony seats. And what was the total value? Well, the total value was 9,780. Oops, need to do that in a different color. Okay, and now what I'm going to do is to try to choose my method. We've defined our variables, we've written our equation, now we're going to solve. Now, I think I'm probably going to use linear combination for this. So on the red here, f plus b equals 900. 12f plus 10b equals 9,780. So to save room, let's move this over to the corner of the paper here. All right. Now, if I'm going to use linear combination, I'm probably going to focus on the b. Multiplying by 10 is very easy. So what I'm going to do is to multiply the top here by negative 10. And what that's going to do is to give me opposites here on the b. So I'm trying to eliminate the b variable. So negative 10 times f, negative 10f, negative 10 times b, negative 10b, and then negative 10 times 900 is going to be negative 9,000. Of course, we don't do anything to this one because we're trying to match it. Okay, so 12f plus negative 10f is going to be 2f. Those cancel out, add to 0. And we have 9,780 minus 9,000 gives me 780. And so I just solve. Divide by 2. And f equals, it's going to be 390. So there are 390 floor seats. We need to go ahead and finish this process up. I think the red is definitely easier to plug back into. So I'm going to plug into the red. The floor seats, which are 390, plus the balcony seats equals 900. So we're going to subtract 390. Balcony seats equals 510. Okay, so we've solved. Now I need to check. Let's check this out. Red, there are 390 floor seats, plus there are 510 balcony seats, equals 900. I'm going to put a question mark there because I'm not 100% sure. I think it's true. Let's see. Yes, 900 equals 900. That checks out. And now let's look for the blue. 12 times, I better check it up here. 12 times the number of floor seats is 390, plus 10 times the number of balcony seats. Balcony seats is 510. It's supposed to equal 9,780. Let's see if that works. 12 times 390. And so we have 4,680 plus 10 times 510 is going to be 5,100. And let's see. 6 plus 1 is 7, 5 plus 4 9. Yes, that checks out. So both the red and the blue have checked out. So the check worked. Now let's do it as a sentence. Now they ask, How many of each type of ticket were sold? Okay. Let's see, they sold, let's see, 390 floor seats and let's see, 510 balcony seats. And that should do it. Again, this is the type of problem we're going to be looking for the quantity, how many there are, and then the quality, the value of each one. All right, about halfway through. This one, I'd encourage you to go ahead and pause the video and try it on your own. Let's see how you did. Let, write, solve, check, sentence. Ryan and Carl spent 28 hours building a treehouse. Ryan worked 4 more hours than Carl. How many did each work? So what we're going to do here, we're going to go through and say let. They're saying how many did each work as in hours. So let's say let R equal the number of hours that Ryan worked. Let K equal the number of hours that Carl worked. And then they ask how many did each work. So let, we've got our let. Now I need to write. It looks like Ryan and Carl spent 28 hours. That looks like a sum. It looks like the total hours for each. So we're going to say that Ryan's number of hours plus Carl's number of hours, that equals 28 total hours. Now, Ryan worked 4 more hours than Carl. All right. So Ryan worked 4 more hours than Carl. I'm going to go with the method that I'd used last time. Who worked more hours? Well, Ryan worked more hours. Carl worked less hours, so we're going to subtract Ryan's hours minus Carl's hours is going to be 4 total hours because Ryan worked more than Carl, 4 more. Okay, well this is set up beautifully for solving using linear combination. We won't have to do a thing. So I'm just going to add these right up. R plus R is going to be 2R. Those are going to subtract away to 0. 28 plus 4 is going to be 32. Divide by 2. R equals 16. And I need to plug this back in. I'm just going to choose red to plug back into. So R, which is 16, plus K equals 28. We're going to subtract 16 from both sides. And K equals 12. Okay, so now we're going to go through and we have done let, we've defined our variables, we've written out the equations, we've solved them. Now we need to go through and check them. So R plus K, we think R is 16, plus K is 12, equals 28, or at least it's supposed to. 16 plus 12, well, yes, then indeed is 28. Also, R minus K, well, R is 16, minus K is 12. It's supposed to equal 4. Let's see, 16 minus 12, yes, that is 4. So we've let, write, solve, we've checked it, and now we want a sentence. Again, we want this conversational. How many did each work? Okay, how many did each work? Ryan worked 16 hours. And Carl worked 12 hours. Alrighty. The difference between 7 times one number and 3 times the second number is 25. That's a mouthful. The sum of twice the first and 5 times the second is 95. Find the numbers. Well, this is a pure problem. There's not much application here. You're just looking at pure algebra. So I would encourage you, go ahead and pause the video, see if you can do it on your own. Let's see how you did. All right. Let, write, solve, check, sentence. Let's look through the, we just have a first number and a second number. So I'm just going to say let x equal the first number and let y equal the second number. Okay, so we've let, defined our variables, and we're going to write an equation now. All right, the first equation is going to come from the first sentence. And this is going to be almost a direct translation. The second equation is going to come from the second sentence. In this case. So the difference between, so difference, that's a subtraction word, so the difference between 7 times one number, so let's say x, and 3 times a second number equals 25. So the difference between, subtraction, you're subtracting things, 7 times one number and 3 times the second number is 25. And also, the sum of twice the first, so the sum of, we're adding, the sum of twice the first and 5 times the second is 95. Okay, so we've written our two equations in this case. Now we want to solve. Now, I personally prefer the combination method, so I'm going to use the combination method here. I've got a positive and a negative version for the y, so what I'm going to do is to simply multiply the top line by 5. Notice I multiply this by 5 and this by 3. So just so I can get those opposites. And this line by 3. That way I'm going to get a negative 15y and a positive 15y, and I can add those out. They're going to add to 0. So 35x minus 15y equals 125. And the bottom line, 6x plus 15y equals, let's see, 15 plus 270, 285. Okay, and now we're just going to add these up. Let's see, 35 plus 6 is going to be 41. 15 plus negative 15 is going to be 0. Equals, let's see, 10, could be 11, 2, 3, 4, 410. All right, divide by 41, and x equals 10. Now we need to plug it back in and try to find out what the other one is. So I don't think there's any huge difference between the two. I'll probably just pick the red. So 7 times x, which is 10, minus 3y equals 25. Let's solve for y. That would be 70. See, so first distribute. Nope. Then combine all of your like terms. Nope. Please remember key change. We could do that. It's optional. Or you will get burned. Then get all your variables onto the same side, which it is. First addition or subtraction. Then multiply, divide. So we think that x is 10 and y is 15. Let's go move this over a little bit. Okay, so we've defined our variables, we've we've written down our equations, we've solved them. Now we're going to check them. So to check them, let's see. In the red, 7 times x, which is 10, minus 3 times y, which is 15, or so we think, equals 25. Well, 7 times 10 is 70, minus 45 is 25. Let's see. Yes, 25 equals 25. That works. Let's try our blue now. 2 times x, well, x is 10, plus 5 times y, y is 15, equals 95. Let's see if that's true. 3 times 10 is 20. 5 times 10 is 50, plus 5 times 5 is 25. 50 plus 25 is 75. 20 plus 75 is 95. That works. So we've checked it. Everything checks out. Let's have a conversation here. Find the numbers, plural. Okay, well, the numbers are 10 and 15. Alrighty. So there we have it. Let, write, solve, check, sentence. Okay, a few more. And we're ready to go. The sum of two numbers is 36. Their difference is 6. Find the numbers. Okay, so this one's short and sweet. I would encourage you to pause the video, see if you can do it on your own. Let's see how you did. Let, write, solve, check, sentence. Okay, so we're going to define the two variables. Let's see, don't think it matters which variables you use. I'm just going to use x and y. Let x equal the first number. Let y equal the second number. So we've defined our variables, done our let statements. Now let's write some equations. So it looks like first equation is going to come from that. Looks like that's comparing the numbers. And the second one is comparing the numbers as well. So the sum of the numbers is 36. So x plus y, the sum, adding them, is 36. And then their difference is 6. So subtract them. That would be 6. Okay, so we did let. Now we've done write. We've written down the equations. Now let's solve these. Now it looks like linear combination is perfect for this one. Positive 1y, negative 1y, those should add to 0 quite easily. 1x plus 1x would be 2x. 36 plus 6 is 42. We're going to divide by 2, and x equals 21. So now we're going to plug that back in. Looks like blue is probably pretty easy to work with. So 21 plus y equals 36. Subtract 21. And y equals 15. Okay, so let, right, we've solved. We have both of them, both of the variables that we defined. Now we're going to check it. Let's see if this works. X is 21 plus y is 15 equals 36. Let's see if that's true. 21 plus 15 is 36. And that works. This is good. And let's try the red equation. So x is 21. Y is 15. Let's see if that works. 21 minus 15 is 6. That's good. So everything checks out. Now let's solve. Excuse me, we've already solved. Let's get our sentence down. Find the numbers. All right, the numbers are let's see, 21 and 15. Okay. Try this on your own, see how you do. Pause video, and let's see how you did. The volleyball club has 41 members. There are 3 more boys than girls. How many girls are there? Okay, well, let, write, solve, check, sentence. Let's define our variables. Looks like we're dealing with um, boys and girls. So let B equal the number of boys. Let G equal the number of girls. And so we say, how many girls are there? All right, well, let's look. We've written our let statements. Let's write some equations. Has 41 members total. Looks like I could use that. There are 3 more boys than girls. I think I could probably use that as well. Let's write our 2 equations. So the volleyball club has 41 members. That's an equation right there. I take the number of boys, add the number of girls. That has to add up to 41. There are 3 more boys than girls. Well, there are more boys. I'm going to say boys is bigger. There are not as many girls. So I'm going to subtract that, and the difference should be 3. Okay, so we're going to add these up. I think that's perfect setup for the linear combination method. So 1b plus 1b would be 2b. 1g minus 1g would be 0. Those cancel out. Subtract to 0. And 41 plus 3 is going to be 44. Just continue to solve. B equals 22. Let's plug that back in. Looks like blue is easy enough to solve for. B, which is 22, plus G equals 41. Subtract 22. And G equals, looks like 19. Okay, so we've written our equations. We've solved them. Now let's check to see if they make sense. In the blue, we have 22, which is the boys, plus the girls, which is 19, equals 41. Let's see if that's true. 22 plus 19 is 30, plus 11 is 41, so that does work. And let's try the red. The boys, which is 22, minus the girls is 19, equals 3. Let's see if that works. 22 minus 19, that is 3. That works. So my check worked out. And now sentence. Let's write a sentence. How many girls are there? There are 19 girls. Okay. And last but not least, the sum of 2 numbers is 15. Twice one number equals 3 times the other. Find the numbers. Okay, so let's go through. Again, I would encourage you to pause the video, try it on your own, and then play it to see how you do. Okay, let's see how you did. The sum of 2 numbers, 15. Twice 1 equals 3 times the other. Find the numbers. Let's go ahead. Let, write, solve, check, sentence. Let, well, let's see. It looks like we're just dealing with 2 numbers. So let x equal the first number. And let's let y equal the second number. Okay, so we've done let. Now let's write. Let's see, the sum of two numbers is 15. That looks like I could get an equation out of that one. Twice one number equals 3 times the other. That's another way to relate those quantities. So I think I could probably get an equation out of that one. So let's try it. The sum of two numbers is 15. Well, that's simple enough. Just take x and y, add them because it's a sum, and that's 15. The red, twice one number, okay, equals 3 times the other. Find the numbers. Okay, well, looks like we could probably use substitution. So again, it's really two different ways you could use the substitution method. The first way is the traditional way, and I'm going to solve for x here. So x plus y equals 15. We're going to subtract y. And we get x equals the opposite of y plus 15. So I'm just going to plug x into the red here. So 2 times something equals 3y. And instead of putting x in the red equation, I'm going to put the opposite of y plus 15. Let's distribute. First distribute. Then combine all of your like terms, which we cannot do. Please remember keychain change or you get burned. Then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. And then we're just going to plug back in. X plus y is supposed to be 15, so x plus 6 is 15. I'm going back to my original. These were my original equations. So I'm taking the blue. I think that y is 6, so I'm just going to the blue and putting a 6 right here, so I can solve for x. So x plus 6 equals 15. Subtract 6. X equals 9. So I think I have my x and my y. Now there is another way to have possibly solved for this. I'd like to go over that as well. Okay, the other way to have solved for this is the sort of new approach to substitution method, which is simply taking and solving both the red and the blue for the same variable and just sticking them together. Okay, so let's try it. X plus y equals 15. Let's just solve for x. X equals the opposite of y plus 15. So we have x by itself. Now let's solve for x in the red. And we have x there as well. So now we're just simply going to stick them together. The opposite of y plus 15 equals 3/2 y. Now, I don't like this fraction, so I can clear that fraction. Multiply everything by 2. So the opposite of 2y plus 30 equals 3y. And you see we get to the same point that we were right here. Subtract 3y from both sides. And now we think y is 6. We could simply plug it back into the blue equation. X plus y is supposed to be 15, so we think y is 6. Subtract 6, x equals 9. So either way, we think that x is 9, y is 6. Whichever method you used, course, you could have used linear combination as well. So, I hope that didn't confuse you. Let right, now we've solved. We're going to check it now. We think that x is 9 and y is 6. We think that x is 9 and y is 6. Let's check these and see if they work out. So, x plus y, so 9 plus 6, is supposed to be 15. Well, that's true. It does work out. In the red, 2 times x, 2 times 9, is supposed to be 3 times y. 2 times 9 is 18. 3 times 6 is also 18. Boom, there you go. So 18 equals 18. We've checked it. It does check out. And let's write a sentence. It says find the numbers. Okay, the numbers are 9 and 6. And there we go. Thank you so much for watching Crazy Math Productions.